Alright guys, so in this video we are going to be building a concurrent chat applications from scratch using Golang and HTMX. I've decided to make this video because I think it's an excellent way to learn concurrency in Go if you're not familiar with it, while building a cool project that I think is going to be a good starting point for any of your future projects. As well, as of the time of recording this video, I couldn't find many references on how to build with WebSockets using HTMX. So this is the service that we're going to be building. And the key point here is that, of course, we're going to be building the concurrent chat, and that has its business logic. But the main difference between building for HTMX and building just a RESTful API that is going to have, I don't know, like React on the front end, is here when we return from the server, instead of returning JSON. You might be familiar with that. So the server is going to be sending HTMX, and on the front end, we'll be replacing those bits and pieces on the UI dynamically. So it's a bit of a different paradigm shift if you're not familiar with this. It's basically the concept of 8OS. If you want to learn more about it. So regarding what we are going to be building, it's the service which is going to have two key components, the clients and the hub. Now, for each socket connection coming in through the wire, the server is going to create a client for each. So you can see here two clients for two connections, and the client is an intermediary, and the client is a man in the middle between the second connection and the hub, right? And then the hub is the broadcaster of messages to the clients and holds application state as well, right? So for example, we're going to have the connected clients. It's going to be a list, and then we're going to have as well the messages of the chats. So here on my VS Code, just to give you a quick overview of the starting template that I have, it is this main goal, which basically has an HTTP that is listening on port 2000, and then I have two handlers that we're going to be building, one for the serving the index.html, and then one for the WebSocket connection, right? So here on the templates, I have an index.html file, which imports the CDN for HTMX, the CDN for the HTMX WebSockets extensions. So here I have a link if you want to learn more about it. And then I just have here tailwinds to do some stylings. Not that this is going to be pretty, I want to be quick and simple to the point. But yeah, this is the HTML with some syntax from HTMX. So here we have a WebSocket connection on this port, on these endpoints. And then here basically we have the chat. So everything inside here is going to be replaced in the future with messages, right? And then here we have a form which has the west send, which is going to be sending to the closest WebSocket connection, which is this one up there, right? So we're going to be going back to these templates in a bit, but for now we have a lot to build. Yeah, let's go. So here on the serve index, what we can do is just do an http.serve file, and then we just serve the templates / index.html. This will do it. I need to first pass this here, right? But I want to add some validations here in case if the URL is different than /, we're going to do something. If the URL.path, we are going to throw an error, right? Not found. And we can do an HTTP status not found. I'm gonna copy this piece of code because we also need to check if the method is different than a get. Just a get for the index, right? So if we compile this, so I also have here this make file, very simple, just to have some shortcuts. If I do make run, so it was an error because you have a nil handler. Okay, so it's early enough. But yeah, we are serving the index. We could comment this, and I think we can test it like this. So let's go here to localhost 3000. And there we go. So we have here the chats. It's serving the index that is working. Then here for the WebSocket connection, what we can do here is we just fill this. And what we can do is that we need to serve the WebSockets and initialize the hub and the client. So here is a connection coming through the wire. And I'm gonna create here a clients.go. And we can also create the hub.go. These are the two files that we're going to have. These are the two components that we saw as well on the diagram. So let's start with the clients, with this method here. Now, this method is going to receive a hub that we currently don't have defined. We're going to go back to it in a bit. And then also an HTTP writer and a request. This is it. Then let's just go and define the hub right now. I think we can do that. Instruct. So from the diagram, we saw that we needed the connected clients, which is going to be, for example, a map of clients. We need here a reference and then the boolean. This is going to represent, for example, we have clients 1 and he's connected. This is going to be true. Clients 2 is going to make connected. Is going to be also true. Just a way to have some state of the connected clients, and then we can also loop over them, right? Then we're going to have 3 channels, one of which is the broadcast, not broadcast, but broadcast, which is going to be a pointer to a message that we're going to define as well. The register, every time someone registers, he comes through this channel, and again, it's going to be sent a client, and the end register, pretty similar to the register one. Let me just go here and define the client as well, since we are already defining everything. Now the client is going to have a reference to the hub. So here for the connection, I'm going to be using the Gorilla WebSockets package that I have. So it's this one, gorilla.con. I really like to use Gorilla stuff, so I'm going to be using this one. And then channel of bytes. This is going to be a send. So basically when the client wants to send something from the browser, so it's this part here. When you send something, we're going to use that channel, and the hub is going to be receiving a size of bytes. Right? So another thing that we can add, for example, is an ID. So if we're building a chat, we can have the username. I love that. I'm just going to have a randomly generated ID for this. So back here on the hub, we also have one more thing to define, which is the message. The message could have, for example, a client ID and the text. Right? This is something that we might revisit in the future, but for now it's this. I just forgot to import Gorilla. So here on the serve WebSocket, there is 3 things that we need to do. It is to upgrade the connection. We also need to create the clients. And then we need to start listening to the hub, basically. So the first thing is that we need to upgrade our connection. Let me just go ahead and do an upgrader. So this is standard for the package that we're using. Just following the documentation, you can get all these values. So I'm just going to use some default values that I have. I usually recommend this. Buffer size as well. Let's do this. Okay. Now here, let's do the connection. Upgrader.upgrade. Right. So here we need to send the response writer, the reader, and we can pass nil. It's fine. Let's handle the error. We can just log it. And then what we need to do is create the clients. We need clients. For the client, we need the hub reference that we have from the parameter here. We also need a connection that we already just created. We need a send channel that we can create here on the fly, make a channel of bytes, and finally we need an ID. So the ID I'm going to be creating here. How can we create this? I think I'm going to be using a simple UID dot new. So I'm going to be importing Google/UID, and then you just have here ID as well. Okay, so now that we have a created client, you can notify the hub. So we can go client.hub.register and send through a message to that channel with the clients, right? So if you remember, the register was receiving a pointer to a client, and here we just got that. So we can just say, hey, this user just got registered, send them whatever you want. So in this case, we can send them the chat history. Finally, we need two methods, which is going to be the write pump, and the other one is going to be the read pump. Okay, so let's go one by one. Let me just define them below here. Okay. All right, so let's start with the read pump. The read pump reads messages from the WebSocket connection. So this is what it's doing. So we have the WebSocket connection. The client here is reading from the WebSocket connection all the time. So that's what we need to do. First thing is, don't forget to just defer this. What we need to do here on this defer is just close the connection. So let's go to the connection, and here I think we have close them. And yeah, let's do it here as well. I'm going to go to the hub, to the unregistered, and just gonna say that we got unregistered. So next we need to do some standard stuff when setting up the WebSocket, which is to set the read limit. I'd set it, for example, max message size. This is going to be a variable that you're going to go back to it. Then we need to set the connection dot set reads deadline, which you can do time dot now. Let me go write this again. Time dot now. I can type dot add wait. Right, so this is going to be a time that we're gonna be setting from the variables as well. And finally, we need to set the connection Pong handler. Set Pong handler. Do we have an auto completion here? We have. Awesome. And inside here, what we do is again we access the connection, and we set the reads deadline to be time dot now dot add Pong waits. Just like the line above. And we can return nil as well, because it expects an error. You don't have one here. Alright, so this is the variables that I have defined. Max message size, and then the Pong wait time. So these values I just copied again from the documentation from the Gorilla. Then let's go ahead and start listening for the read message. So there's a method for the connection, which is reads message. This is going to read as bytes. So what we have here is message type that you don't care about. We have the text message and an error. So we can just, for example, print f, and I want the value, and I'm gonna stringify this text. So we can just have some logs. So here, if there is an error, what we can do is just, we should handle this error. It's recommended that we do it. If you're going to production, we can just continue here. If you want to handle this, what we can do here is this. So from the documentation, if it's an unexpected close, we print it. Here we could just panic, we could do whatever we want, but the idea is that we are closing the connection from the user, right? So if you just want to go simple, just do the continue. If you want to make this production level, add some more error logging, and as well handle the error properly. So now back to the message. What we need to do here is that we need to parse the message and send to the hub. So what's going to happen in the end is this. So this is what we want to do, broadcast, and we want to send basically a message with the client ID, and this is going to be the connection.id and the text, right? Text is what we want, and if we just pass text, this is not going to work because it's not of the type that we want, which is a string. This is going to be a string of JSON, because from HTMX, what it does, it's going to be sending here on the input when we send send, it's going to be sending an array, an object with the text and header properties. So let's have here the parsed message. I think I'm going to use this message as well. The correct way would be to do something like this. WebSocket message, for example, and here we have headers, interface, anything. So this is what they're going to be sending. Here is going to be the text. Let me just do JSON has text, and here I don't care about the header, but we can just do headers, and then here we can just do the headers like this. So I'm gonna use this type instead, so that we don't confuse with the actual message. And then let's create a reader, bytes.reader, because we are coming from bytes, which is the text, right? Yes. So why is this not? We need to do new reader. Then we need a decoder, the JSON decoder. It's going to be JSON.new decoder, and we pass in the reader. Then let's just do the decoding. Now that you have the decoder, decoder.decode, put it inside message, and if there is an error, let's just log.printf and say that error v and error. Okay, and here what we can do is send the message dot text. So this is going to be sending the message from the connection to the hub. We're going to be sending a message to the broadcast. Let's do the read pump. It's not being in use. I think it's because there's an error somewhere. It's because it's not being used. So let's go back to the main Go. Okay, so here on the main index, now that we just created the serve WebSockets and we created the write pump as well. So we created the read pump. We just need to define the write pump as well. But you can go back and close this error. So we need to create the hub. So I'm going to be making a hub here, send new hub, and then we go back. Let me go back to the hub method. Oops. And create a function called new hub. That is going to be returning a pointer to hub. Like so. So it requires client, which we can just make a map like so. Then we have the broadcast channel. We also have auto-completion for this, the register, and finally the unregister. So this is the hub, so this should be working. But now there's a thing that we need to do, which is once a go routine with the hub.run, which is going to start listening for the broadcasting. So let's create that method. It is the only method from the hub that we have. Run doesn't receive anything. And here we can leave this empty for now. Right? Then here on the client, let's finish up writing the write pump. So again, let's start by closing any connection if something bad happens here. And we also need some extra behavior here because we have a ticking behavior on the write pump. So we can do that by creating a ticker for the WebSocket, so new ticker. And we can pass in the ping period, which we not have defined. So let's go ahead and define this on the constants here. So the ping period is going to be sending pings to the peers, and it must be less than the Pongo weight, right? So I have this decommented here. If you want to follow along, I have the code in the description as well below. So here the ticker. Let's just start listening and then we handle that properly. So the first thing, let's do a select. If there is a message, okay. So we need to receive from the send here. And let's do a connection, set write deadline, time.now, adds, and let's do the write wait, another variable that we need to add, and I think it's the last one. So the write wait, it is the time allowed to write a message to the peer, okay? So here below where you were. So if it's not okay, what we need to do is basically send an empty message to the client, because what happened is that probably the hub has been shut down. So what you can do is just write message and have a code of close message and then just send empty bytes there. It's fine. So now at this point, what we are is that we are reading a message that has been sent to us. So let's do that. So let's do a connection dot next writer and do a WebSocket dot text message, because it's going to be a text message. The error is different than nil, return. Right? Then we can just do this dot write and send the message in. As simple as that, right? And then at the end, what we can do and what we need to do is close this reader and handle the error accordingly, which we are not because we're lazy. So one last thing that we can do here is more of a performance boost, which is add the queued messages from the chats to the current WebSocket message. So basically compile all of them into one big message and just send them. So what you can do here is a for loop like this, and the length of, or the count, is going to be basically the length of the channel messages. And inside here, we do is just write message, right? So we're just writing the whole message that are there. So we might have, server might be slow, and then we can just send them all here instead of blocking it. And here I've just started this little piece of code, which is for the ticker. So just setting a deadline, and then we're writing the message with the ping message for the clients that to know that we're alive. Okay, so this is the write pump and the read pump as well. So this client functionality is pretty much done. Now let's go to the back to the fun part and write the run. For the run here, we also are going to be listening. So let's have a for and select. And these are the three channels that we're going to be listening for. The first one is the registers. It's pretty easy to handle this. So let's just do h.register. And let's do the clients. And basically we are registering a client here. So client true. Now note that this is not concurrent. In Go, maps are not concurrent. If you want to make this production safe, you could just add here a lock. So h.lock. So in the code that I have in my description, you can see this implemented with a lock. So if you want to do this yourself, you can check the code, or you can basically just add here mutex and can lock here. So lock, and then you could unlock after it. I'm gonna keep this simple and just leave this out. So after this, I'm just going to log that the client has been registered, just so we can have some logs and visibility. And pretty much this is the register part. So let's also handle the unregister, which is pretty similar to the register. So here, let's listen from this. Okay, so instead of, here instead of just adding, let's check if first it exists, because there is a chance it might not exist. And if it's okay, then we need to do some things, which is delete from the h.clients, this clients. But first we should close the connection from the clients.send channel, okay? Then let's handle the last channel, which is the broadcast. Okay, so here we have the message from the broadcast. And what I want to do here is just, I didn't define the messages, so let's go back to the hub here and define messages. Messages can be just a slice of message. And then let's go messages, append, MSG, there we go. And finally, we need to broadcast this. So let's loop over all of the clients that are connected and do a client.send. And here, this is where we're going to send the HTMX to the client. If you were building for JSON, you'd send JSON here. So let me just create a method called get message template. And I'm going to be passing the message to the template. Default, we just close the client.send, pretty important as well, so I don't have any leaks. And we just might as well just delete it because the client connection dies. We are going to be waiting, so we might as well just consider him out of the connected clients. Here, what we need to return is a byte slice, I think. Or is it a string? It's a byte slice, so let's send the message, which is going to be a pointer to message. Now, this is where we need to create a new message template. So, as we saw, we have this index, and inside here, on the chat room, what's going to happen is we're going to be sending an HTML template with a message in it. So it's going to be, for example, if you're familiar with React, you're going to send the message components, right? This is similar to what we're going to be building. So let's go here and create a message.html. And the message.html could just be a div with attributes in it. So if you're familiar with Go templates, we can pass in variables. For example, we know that we have the text attributes there, and that we also have the client ID. So these are coming from the message. So yeah, we know that we can access these two variables from that message. So let's go ahead and define some HTML CSS for this. So this is what I've just come up with. Basically, the message has the same ID as the chat room, which is going to be added inside of the chat room with this swap. So if you get back to the HTMX documentation, you can have a look on how we can swap them and what's the properties. So here I have a before end. So it's going to be added at the last element of the list inside of it. And here I just have a client ID and a text with some styling, right? So back here at the get message template function, there is a couple of things that we need to do. First is get the template and parse it, send the variable message into it, and then convert that template into a byte slice, because that's what the channel is going to be receiving. So let's get a template. This is pretty simple. Pretty simple if you have worked with templates from Go before. Parse files. For me, it's inside template / message .html. We can just handle the error. We can just handle the error like this. And then we need to render the template with the message as the data. So I'm just going to have rendered message. It's going to be bytes.buffer. And let's do a template execute. So now that we have the template, we can execute it and pass in the rendered message and the variables that are going to be replaced. Again, I'm going to handle it pretty simply. template parsing, failed, and at the end we just return the rendered message dot bytes. Okay, so this needs to be imported like so. This is working, awesome. Now we can save and we don't have any error. So you can see here that we're sending to the channel the template that has been parsed as bytes, right? Okay, so we can finally test this. Let's just make sure that we are running this Go routine, the run, and that here we have the client registers. I also added this unregistered log so we can see the client being unregistered. And then in the client we have this Go routine and the write pump and the read pump as well. Okay, let's try to make run. So no errors. Let me go to localhost 3000. And here we have the UI, everything is working. We have a log of a client has been registered with his ID. So let me just refresh the page. And we see that he got unregistered and registered again with a new ID. So in theory, it's a new client. We have anything in the response. And what happens if we send a message? So hello world. So a message has been sent. Let me see if I can increase the font of the console so you guys can see. So the message has been sent with text and then headers. These are the headers that I said that we can ignore. And then the server responded with HTML, right? So, and then HTMX, what it did is it went to this chat room and it just added this message component inside here. So dynamically swapping in real time the message that comes from the server. So this is working. Let's try to have a new client because the chat is no fun if you're not chatting with anything. And a problem I see is that we don't have messages. We don't have the history of messages that has been sent before. So if I send here a message, I see that it has been sent here. So if this is the new client, you can see it's different. But we don't have a history of message. How can we fix that? Let's try to fix that. It's a pretty simple solution. Let's go back to the run. And when the client has been registered, you might consider looping over all of the messages. And then sending him a message. So let's do client.send and just go and get message templates, message. There we go. So let's see if this works. I think it will. It doesn't compile because it doesn't exist. So here I have one client and then I have one here that I'm going to open in the bit. Let me just create some messages, some history. Okay, so I'm going to open this client here on again, and we can see that it loads with the history, right? So if I refresh this any amount of times, you can see that we are sending the history. Now, if you're going to production, what you could probably implement here, instead of looping all over the messages, because this is going to be expensive really quick, could have, for example, send 40 messages, 50 messages, whatever you want to send, but don't consider sending everything, at least not paginated. So guys, this is it. If you understand what I teach you in this video about WebSockets and a little bit about HTMX, you can basically build anything in Go with WebSockets, right? So if you like this video, consider leaving a thumbs up and maybe subscribing, and see you in the next one. Bye bye.